Hello everyone, welcome my dear students. Welcome to tchr with you always. Yes students, yes, how are you all doing? Yeah, I hope you all are fine. Students, in today's session, I have brought a very important concepts in front of you from the chapter aldehydes, ketones and carboxylic acid. Okay, so what we are going to study in today's session? Yes, we are going to study some important naming reactions from aldehydes, ketones, and carboxylic acid. Students, what is this naming reaction? See, the scientist who worked on this uh, reactions, the name of the scientist will be given to this particular process. We call it as naming reaction, and all the naming reactions is very important for you to understand. Okay, even exam point of view also, all the naming reactions is very important. You have to understand and practice it very well. Yeah. So once again, I welcome you all to Teacher Dot. So are you all ready to listen to today's session, students? So listen carefully, follow the entire session from the beginning to the end. Just go through the entire session, and after the session is over, you have to start practicing this naming reactions. Okay, so in aldehydes, ketones, and carboxylic acid, there are so many naming reactions to prepare aldehydes or ketones, or to see how this aldehydes, ketones, carboxylic acid shows some chemical properties. Yeah, what you have to do is list all these naming reactions, which are the reactions present. You list, and every day at least five naming reactions you have to keep practicing every day. This is how it is gonna help you. Fine. So I hope already you all have downloaded the teacher app. You all have teacher app with you, and yeah, are you going through the recorded sessions and all the videos that is available? I hope you all are doing that, and definitely it is helping you in a good way, right? Okay, students, once again I welcome you all to today's session. Let us start with the first naming reaction of aldehydes, ketones, and carboxylic acid, that is Rosenmund's reduction. So, students, this Rosenmund reduction is a reaction to prepare aldehyde. Using in this reaction, in Rosenmund's reduction, what we can do is we take acyl halide to prepare aldehyde. So Rosenmund reduction is to prepare aldehyde. Okay, you can prepare any kind of aldehyde, aliphatic or aromatic. So there is a particular example given here. Here you can observe what I have done is I have taken benzoyl chloride and converted to benzaldehyde. So in general, if I need to explain this reaction in general, what I can do is if I take, I'm writing it, the general equation. If I take acyl chloride, what is RC double bond OCl? Yes, it is acyl chloride. So what I do? Reduction. Students, what is the meaning of reduction? Reduction is nothing but it can be addition of hydrogen, right? So what I'm performing here is addition of hydrogen in the presence of palladium metal on barium sulfate, palladium on barium sulfate as a catalyst. So what I'll be doing here, addition of hydrogen. So how this hydrogen will be added? Students, you know that if a bond between this carbonyl carbon and chlorine breaks, you know carbon here is a partially positive charge, correct? And chlorine will be negative charge, yes. Now, what happens when the bond between this carbonyl carbon and chlorine breaks? The chlorine will go out with the hydrogen as a byproduct, HCl. With one hydrogen, it will go out as HCl, right? So what happens to remaining one hydrogen? Very simple way. What you have to do, you replace chlorine with one hydrogen. So what you will get? Yeah, R C double bond OH, which is nothing but aldehyde, right? The simple way of understanding this concept is, since you have taken hydrogen H2, one chlorine will go out with one hydrogen as a byproduct HCl. What you do? Replace this chlorine atom with one hydrogen atom. So actually what happens here, the palladium, see, R C double bond OCl, once the chlorine is out, this carbon is partially positive. But what this palladium will do? This palladium is a positive metal which gives out two electrons and it converts to palladium, giving out two electrons. So where this two electrons will go? Two electrons will go towards carbon and carbon will get negative charge. When the two electrons from palladium is given to carbonyl carbon, the carbonyl carbon gets negative charge. So a hydrogen will be added towards the negative charge and you will get R C double bond O H. This is the way how hydrogen is added to carbonyl carbon. Is it clear? Now, for example, let me take a simple example, that is acetyl chloride. CH3 C double bond O Cl, right? So what do we call this compound as? Yes, we call it as acetyl chloride. Now what I have to do? I have to convert this acetyl chloride to aldehyde. So through Rosenmund's reduction, that means I will add hydrogen in the presence of palladium over barium sulfate as a catalyst. Now what you do? Yes, as I told you the mechanism, carbonyl carbon and the chlorine, the bond breaks between them and what byproduct you will get is HCl. This is the easy way of understanding. I told you palladium, which is a electropositive metal, gives it electrons to the carbon atom and carbon atom becomes negative charge and to that negative charge hydrogen will be added and therefore you will get the product CH3 C double bond OH. So students, what is this CH3 C double bond OH? Yeah, acetaldehyde, or if you want to write the IUPAC name, it is ethanol. So you got the aldehyde, that is ethanol. This is all about Rosenmund's reduction. Now, here in front of you is an example of benzoyl chloride. What is the structure of benzoyl chloride? Yes, it is C6H5 C double bond O Cl. So what you did? Replace the chlorine atom with one hydrogen atom. You will get C6H5CHO, which is benzaldehyde, which happened in the presence of palladium over barium sulfate as a catalyst. Is it clear, my dear students? So this is all about Rosenmund's reduction, the conversion of acyl chloride to aldehyde. So once you have understood the concept, any example, any kind of acyl halide is given, you will be able to convert it into aldehyde. Fine. So let's move on to the next important reduction reaction, that is Stephen reduction. This is also one of the best method to prepare aldehyde. So in Stephen reduction, here also what we do is we perform reduction reaction. We take the reactant, that is nitrile. So what is nitrile? Yes, the alkyl group containing CN or C triple bond N functional group. Cyano group. It can also be called as cyano group, otherwise nitrile group. So this nitriles we are going to convert to aldehyde, and this is known as Stephen reduction. So here nitriles will be reduced in the presence of stannous chloride in the acid medium. Stannous chloride, that is SnCl2, and in the acid medium we convert nitriles to what? Aldehyde. Now let us discuss. Here the reaction is given. Let us see how nitriles will be converted to aldehyde. So I have, in general I am writing R C triple bond N. So what it is? This is nitriles. So what I do? I treat this with stannous chloride. Right. So you know that in the carbon here and nitrogen, yes, nitrogen will be highly electronegative and compared to carbon which will be positive. Right. What this tin Sn, stannous chloride, this tin will do? That is Sn2 plus. The oxidation state, see, since it is SnCl2, the oxidation state of tin will be Sn2 plus, and it gives out two more electron and convert to Sn4 plus, giving out two electrons. And where these two electrons will go, dear students? Yeah, two electrons will go towards the carbon atom. Okay? Yeah. So what happens, students, when the two electrons go towards carbon atom? Yeah, carbon atom will gain negative charge. Now, you know that when I have taken two molecules, if I have taken two molecules of hydrogen halide, hydrogen chloride, add one hydrogen to carbon and one hydrogen to nitrogen. So you will get RCH double bond NH. Is that clear? So what happens one pi bond? When one pi bond is broken, two hydrogens will be added to the one carbon and one nitrogen. When you add one hydrogen to carbon and one hydrogen to nitrogen, the pi bond, one pi bond must be removed. Is that clear? So how this hydrogen I added? Through HCl. The two molecules of HCl will give the hydrogen, and you will get an intermediate called as imine. What is this? This is an intermediate imine. Now what I do? To this imine I perform hydrolysis. Hydrolysis means just treat with water. ಸೊ ಏನಾಗುತ್ತೆ ವಾಟರ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ, ಸಿ ವಾಟರ್ ಅಂದ್ರೆ ಏನೋ ನಿಮಗೆ ಗೊತ್ತು. ವಾಟರ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ H2O, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಸೊ ವೆನ್ ಯು ಟ್ರೀಟ್ ವಿತ್ ವಾಟರ್, ಇಟ್ ಇಸ್ ಸಿಂಪಲ್ ವೇ ಆಫ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. ಈ ರೀತಿ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗುತ್ತೆ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಈ ರೀತಿ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆದ್ರೆ ಏನಾಗುತ್ತೆ? ದಿಸ್ ಇಲ್ಲೇನಿದೆ NH ಗೋಸ್ ವಿತ್ ದಿ ಹೈಡ್ರೋಜನ್ಸ್ ಆಸ್ NH3 ಬೈ ಪ್ರಾಡಕ್ಟ್. ಹಾಗಿದ್ರೆ CH ಡಬಲ್ ಬಾಂಡ್ N, ಕಾರ್ಬನ್ ನೈಟ್ರೋಜನ್ ಜೊತೆ ಡಬಲ್ ಬಾಂಡ್ ಆಗಿತ್ತು. ನೌ ಇಟ್ ಫಾರ್ಮ್ಸ್ ಅ ಡಬಲ್ ಬಾಂಡ್ ವಿತ್ ಆಕ್ಸಿಜನ್ ಆಟಮ್, ಅಂಡ್ ವಾಟ್ ಯು ಗೆಟ್? RC double bond OH. So what is this RC double bond OH, dear students? Yes, it is aldehyde, right? RC double bond OH is nothing but aldehyde. Is it clear? See, mechanism ಎಲ್ಲೋ explain ಮಾಡಿರಲ್ಲ. You have to understand the mechanism for a clear understanding of that particular reaction. So once again I'll tell you, for example, if I've taken CH3 C triple bond N. So how do you name this? CH3 C triple bond N. Yeah, it is ethane nitrile. So two carbon atoms CN cyano group ನ ಸೇರಿಸಿ ನೀವು ಕೌಂಟ್ ಮಾಡಬೇಕು. So it is ethane nitrile. Okay, so what I do? I have to perform reduction reaction. Reduction means addition of hydrogen. So in the presence of stannous chloride as a catalyst and the acid medium HCl. So if I've taken two molecules of HCl, ಏನಾಗುತ್ತೆ? This stannous chloride SN2 plus ಇರೋದು ಕಾರ್ಬನ್ನಿಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೊಡುತ್ತೆ. So carbon also becomes negative charge and nitrogen also becomes negative charge. So what you do? Add one hydrogen to carbon and also to nitrogen. ಸೊ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಇರೋದು ಒನ್ ಪೈ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಿ ಡಬಲ್ ಬಾಂಡ್ ಆಗುತ್ತೆ. ಸೊ ಯು ವಿಲ್ ಗೆಟ್ CH3 CH ಡಬಲ್ ಬಾಂಡ್ NH. ಸೊ ಈ ಸ್ಟೇಟ್ ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಸ್ಟೇಟ್, ದಟ್ ಇಸ್ imine. Now, what you have to do? You have to perform hydrolysis. On performing hydrolysis, the CH3CH group is oxidized. On addition of oxygen, it turns to CH3CH ಇರೋದೇನಾಗುತ್ತೆ? C double bond OH. And NH group will go out as ammonia NH3. So, what you get? Ethane nitrile is converted to ethanol, right? Is it clear, my dear students? So any nitrile group is given in the presence of stannous chloride and the medium, acidic medium, we can call it as acidified stannous chloride. You can convert the nitrile group to aldehyde group. Or simple way of understanding, ನಿಮಗೆ ಯಾವುದೇ ಪ್ರಾಡಕ್ಟ್ ಕೊಟ್ರು ನೀವೇನ್ ಮಾಡ್ತೀರಾ? ಈ ನೈಟ್ರೈಲ್ ಗ್ರೂಪ್ ನ ನೀವೇನ್ ಮಾಡ್ಕೋಬೇಕು? ಈ alkyl group will be as such and you will be converting the nitrile group to aldehyde C double bond OH. So this is all about Stephen's reduction. So till now, students, we have understood two methods of preparing aldehyde. Both the methods is reduction method, correct? Rosenmund's reduction ಆಗಿರ್ಬೋದು, Stephen's reduction ಆಗಿರ್ಬೋದು. Through addition of hydrogen ನಾವೇನ್ ಮಾಡ್ತೀವಿ? We convert nitrile group or acyl chloride to aldehyde. So I hope you all are understanding the concept. Now, I will move on to the next reaction, that is Etard's reaction. Etard's reaction ಅಂತ ಹೇಗೆ ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದು ಅಂದ್ರೆ, Etard's reaction ಅಲ್ಲಿ ನಾವು ಏನ್ ಪ್ರಿಪೇರ್ ಮಾಡ್ಬೋದು? We can prepare benzaldehyde, not the aliphatic one. We can prepare only benzaldehyde. Okay, so what we do to prepare benzaldehyde? What is the reactant I will take? I will take toluene as a reactant. So toluene ಗೊತ್ತಿದೆ ಅಲ್ಲ ಎಲ್ಲರಿಗೂ? Benzene ring, methyl group is attached to benzene ring. We call it as toluene. To that, I will oxidize the methyl group of toluene using chromyl chloride. So you would have observed here, students will observe ಮಾಡಿ ನಾನು ಇಲ್ಲಿ ಏನು ತಗೊಂಡಿದ್ದೀನಿ? I have taken toluene. So what is chromyl chloride? This is chromyl chloride. Chromyl chloride ಅಂದ್ರೆ CrO2Cl2. So chromyl chloride I have taken in the presence of carbon disulfide as a solvent. ಈ CS2 ಏನಿಲ್ಲಿ? It is a solvent. Non-polar solvent. ಇಲ್ಲಿ ನಾನು CS2 ತಗೋಬಹುದು, carbon disulfide, or I can take CCl4, which is a non-polar solvent. And what this chromyl chloride will do? It will form a complex like this with the CH3 group. You can observe the complex here, that is CHOCROHCl2 twice ಅಂತ complex form ಆಗಿದೆ. This complex on hydrolysis, that is treating with the hydronium ion, gives benzaldehyde, right? So let us discuss more about this Etard's reaction. So are you able to understand, dear students? So now you observe what I had taken is toluene. Toluene andre ಏನು? Yes, it is C6H5 CH3 group attached to the benzene ring, right? So what I have to do, I have to oxidize the methyl group of the toluene using chromyl chloride. So toluene ಇದೆ, ಕ್ರೋಮೈಲ್ ಕ್ಲೋರೈಡ್ ಜೊತೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಹೇಗೆ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ನಿಮಗೆ ಡೌಟ್ ಇರುತ್ತೆ, ಕರೆಕ್ಟ್? ಇಲ್ಲಿ CH3 ಕಾರ್ಬನ್ ಅಟ್ಯಾಚ್ ಟು 3 ಅಂದ್ರೆ ಕಾರ್ಬನ್ಗೆ 3 ಹೈಡ್ರೋಜನ್ ಇದೆ, CH3. ಕ್ರೋಮೈಲ್ ಕ್ಲೋರೈಡ್ ನ ನಾನು ಹೇಗೆ ಬರಿತೀನಿ ನೋಡಿ. ಕ್ರೋಮೈಲ್ ಕ್ಲೋರೈಡ್ ಅಂದ್ರೆ ಏನು? CrO2Cl2 ಅಲ್ವಾ, ಅಂದ್ರೆ CrO2Cl2 ಅಂದ್ರೆ ಈ ತರ Cr ಡಬಲ್ ಬಾಂಡ್ O double bond O. So this is CrO2Cl2 chromyl chloride complex ಇದೆ. In the presence of yes non-polar solvent. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ students, what happens is homolytic cleavage. ಓಕೆ, ಈ CH2 ನಾನು ಈಗ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಬರಿತೀನಿ ನೋಡಿ. ಸೊ CH3 ಇದೆ ಅಲ್ಲ, ಸೊ CH3 ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಬರಿತೀನಿ, ಓಕೆನಾ? ದಿಸ್ ಇಸ್ ಫಾರ್ ಯುವರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಆಫ್ ದಿ ಮೆಕ್ಯಾನಿಸಮ್. CH ಇನ್ನ 2 ಹೈಡ್ರೋಜನ್ ಹೀಗೆ ಬರಿತೀನಿ. Now, homolytic cleavage happens between the chromium and oxygen. Homolytic cleavage ಅಂದ್ರೇನು? Equal distribution. Homolytic cleavage ಆದ್ರೆ ಏನಾಗುತ್ತೆ? Equal distribution of electrons ಆಗುತ್ತೆ. Same way here also a homolytic cleavage happens between the carbon and hydrogen. So ಇಲ್ಲಿ homolytic cleavage ಆದಾಗ ಏನಾಗುತ್ತೆ? Now this hydrogen forms bond with the oxygen, sharing of electron. Same way this hydrogen forms bond with the oxygen atom. So when this hydrogen forms bond with the oxygen atom, now a complex will be formed, dear students. So ಅವಾಗ ಇಲ್ಲಿ ಏನಿರುತ್ತೆ? 2 hydrogens has formed a bond. ಇಲ್ಲಿ ಏನಿರುತ್ತೆ? Only CH and you will get here OCRO HCl2, ಕರೆಕ್ಟಾ? ಎಷ್ಟು ಹೈಡ್ರೋಜನ್ ರಿಮೂವ್ ಆಯಿತು? 2 ಹೈಡ್ರೋಜನ್. ಸೊ ಇಟ್ ಫಾರ್ಮ್ಸ್ ಅ ಕಾಂಪ್ಲೆಕ್ಸ್ ಟ್ವೈಸ್ OCRO HCl2 twice. Is it clear now? Now upon hydrolysis ಇದನ್ನ ನಾವು ಹೈಡ್ರೋನಿಯಂ ಅಯಾನ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದಾಗ, so now the complex breaks on treating with hydronium ion. Now the complex breaks and yes, you will get on oxidation, you will get benzaldehyde CH double bond O, that is benzaldehyde. Is it clear? So this is all about Etard's reaction. So once again we shall recall which are the 3 important naming reactions, also the 3 important reactions for the preparation of aldehyde we discussed in today's session is Rosenmund's reduction. In Rosenmund's reduction we prepare aldehyde using acyl halide, and then the second one is Stephen's reduction. Stephen's reduction ಅಲ್ಲಿ ನಾವೇನ್ ಮಾಡ್ತೀವಿ? Here also we prepare aldehyde using nitriles. Nitriles will be treating it with stannous chloride in acidic medium. ಸೊ ದ ಮೆಕ್ಯಾನಿಸಮ್ ನೀವೊಂದು ಸ್ಕ್ರೀನ್ಶಾಟ್ ತಗೋಬಹುದು. ಸ್ಕ್ರೀನ್ಶಾಟ್ ತಗೊಂಡು ನೀವು ಪ್ರತಿ ಸರಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದಾಗ ನೀವೇನು ಮಾಡ್ಬೋದು? ಈ ಮೆಕ್ಯಾನಿಸಮ್ನ ಅರ್ಥ ಮಾಡಿಕೊಂಡು ನೀವು ರಿಯಾಕ್ಷನ್ನ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಬೋದು. ಸೊ ದಟ್ ವಿಲ್ ಗಿವ್ ಯು ಅ ಕ್ಲಿಯರ್ ಪಿಕ್ಚರ್ ಆರ್ ಅ ಕ್ಲಿಯರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಆಫ್ ದಿ reaction. So and the next one is Etard's reaction, where we are going to prepare benzaldehyde using toluene. Here we treat toluene with chromyl chloride and it will form a complex and oxidize the methyl group to aldehyde group. This one also you can just take a screenshot of the mechanism. Here very simple students, the homolytic nanil heldala, this part the homolytic cleavage happens and the hydrogen forms bond with the complex. Okay, so this is a mechanism for Etard's reaction. So is it clear, dear students? So this is all about ಪ್ರಿಪರೇಷನ್ ಆಫ್ ಆಲ್ಡಿಹೈಡ್ ಅಲ್ಲಿ ಬರೋ ಅಂತ ನೇಮಿಂಗ್ ರಿಯಾಕ್ಷನ್ಸ್ಗಳು. ಇದನ್ನು ಬಿಟ್ಟು ದೇರ್ ಆರ್ ಸೋ ಮೆನಿ ಅದರ್ ರಿಡಕ್ಷನ್ ರಿಯಾಕ್ಷನ್ಸ್ ಆರ್ ದ ನೇಮಿಂಗ್ ರಿಯಾಕ್ಷನ್ಸ್ ಐ ವಾಂಟೆಡ್ ಟು ಡಿಸ್ಕಸ್ ವಿತ್ ಯು ಆಲ್ ಟುಡೇ ಇನ್ ದಿಸ್ ಸೆಷನ್. That is the first one in that is Clemmensen's reduction. ಕ್ಲೆಮೆನ್ಸನ್ ರಿಡಕ್ಷನ್ ಅಂತ ಬರುತ್ತೆ, ವಲ್ಫ್ ಕಿಶ್ನರ್ ರಿಡಕ್ಷನ್ ಅಂತ ಬರುತ್ತೆ. ಇದೆಲ್ಲ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ನೇಮಿಂಗ್ ರಿಯಾಕ್ಷನ್ಸ್ ಆಗಿರುತ್ತೆ ಈ ಆಲ್ಡಿಹೈಡ್ಸ್, ಕೀಟೋನ್ಸ್, ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ. ಓಕೆನಾ? ಸೊ ಏನಿದು ಕ್ಲೆಮೆನ್ಸನ್ಸ್ ರಿಡಕ್ಷನ್ ಅಂದ್ರೆ, ದಿಸ್ ಇಸ್ ಒನ್ ಆಫ್ ದಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಶೋನ್ ಬೈ ಆಲ್ಡಿಹೈಡ್ಸ್ ಅಂಡ್ ಕೀಟೋನ್ಸ್. ಈ ಆಲ್ಡಿಹೈಡ್ಸ್ ಕೀಟೋನ್ಸ್ ಏನ್ ಮಾಡುತ್ತೆ, ವೆನ್ ಯು ಟ್ರೀಟ್ ದಟ್ with a particular reductive agent, it will convert to hydrocarbons. So ಈ Clemmensen's reduction ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ನಾವು ತಗೊಂಡಿರೋ ಆಲ್ಡಿಹೈಡ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ನಾವು ತಗೊಂಡಿರೋ ಕೀಟೋನ್ ಆಗಿರ್ಬೋದು, both will convert to hydrocarbon. ಸೊ ಇದನ್ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಕನ್ವರ್ಟಿಂಗ್ ಆಲ್ಡಿಹೈಡ್ಸ್ ಅಂಡ್ ಕೀಟೋನ್ಸ್ to hydrocarbon in the presence of zinc amalgam in acidic medium. Okay, ಇದನ್ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, Clemmensen's reduction. So simple way ಅಲ್ಲಿ ನೀವು ಇಲ್ಲೊಂದು ಎಕ್ಸಾಂಪಲ್ ನೋಡ್ಬೋದು. What is this example I have taken? Yes, it is propanone. ಕರೆಕ್ಟಾ? ಪ್ರೊಪನೋನ್ ಅಥವಾ ಕಾಮನ್ ನೇಮ್ ಅಸಿಟೋನ್ ಅಂತ ಹೇಳ್ಬೋದು. ಪ್ರೊಪನೋನ್ ಅಲ್ಲಿ ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಕಾರ್ಬೋನಿಲ್ ಗ್ರೂಪ್ ಏನಿದೆ is converted to CH2 hydrocarbon group in the presence of zinc amalgam in acidic medium. ಸೊ ಏನಾಗ್ತಿದೆ ಇಲ್ಲಿ, ನೀವು ಏನ್ ಮಾಡಬೇಕು, ದ ಸಿಂಪಲ್ ವೇ ಆಫ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಇಸ್ ಪ್ರೊಪನೋನ್ ಈ ಕಾರ್ಬೋನಿಲ್ ಗ್ರೂಪ್ ಏನಿದೆ ಇಟ್ ಇಸ್ ಕನ್ವರ್ಟೆಡ್ ಟು ಡಬಲ್ ಬಾಂಡ್ ಆಕ್ಸಿಜನ್ ತೆಗ್ದಿದ್ದಾರೆ, ಹೈಡ್ರೋಜನ್ಸ್ ಆಡ್ ಮಾಡಿದ್ದಾರೆ. ದಟ್ ಇಸ್ in general, if it is R C double bond OH aldehyde ತಗೊಳ್ಳಿ ಅಥವಾ R C double bond R dash ketone ತಗೊಳ್ಳಿ, anything maybe. So when you perform this Clemmensen's reduction in the, that is in the presence of zinc amalgam HCl, you perform a Clemmensen's reduction taking ಏನಿದು ZnHg ಅಂದ್ರೆ a mixture of zinc and mercury which is called as zinc amalgam. ಇಲ್ಲಿ ನೀವು ಏನ್ ಮಾಡ್ತೀರಾ, remove the oxygen atom and you will be adding hydrogen atom, so you will get RCH3 ಆಗುತ್ತೆ ಇದು. ಕರೆಕ್ಟಾ? ಸೇಮ್ ವೇ ಇಲ್ಲೂ ಅಷ್ಟೇ, R ಸಿ ಡಬಲ್ ಬಾಂಡ್ ನೀವು ಎರಡು ಡಬಲ್ ಬಾಂಡ್ ಬದಲು ಎರಡು ಹೈಡ್ರೋಜನ್ ಆಡ್ ಮಾಡ್ತೀರಾ, ಸೊ ಇಟ್ ಇಸ್ RCH2 R dash. So see, this way you convert the aldehydes or ketones to hydrocarbons. Now let us see an example how this conversion is possible. Now students, for example, if I have taken a ಅಸಿಟಾಲ್ಡಿಹೈಡ್ ತಗೊಂಡಿದ್ದೀನಿ ಅಂತ ಅನ್ಕೊಳ್ಳಿ, CH3 C double bond OH, correct? You know that in the carbonyl carbon and carbonyl oxygen, oxygen is highly electronegative, right? And carbon is positive, correct? Oxygen will be highly electronegative and carbon will be positive. So what this zinc will do is, zinc amalgam ಅಲ್ಲಿ zinc ಇದೆಯಲ್ಲ, the oxidation state of zinc is Zn2 plus, correct? That zinc will give 2 electrons. ಯಾರಿಗೆ ಕೊಡುತ್ತೆ ಈ 2 electrons ನ? Yes, zinc will give this 2 electrons to the carbon atom. Okay, so when zinc gives 2 electrons to carbon atom, ಏನಾಗುತ್ತೆ? Yeah, carbon will obtain negative charge. So ಈಗೇನಾಗುತ್ತೆ? So now this pi bond, ಒಂದು pi bond break ಆದ್ರೆ that goes on the oxygen as negative charge, 2 electrons. ಈಗ ಆಕ್ಸಿಜನಿಗೂ 2 electrons ಬಂತು, ಕಾರ್ಬನಿಗೂ 2 electrons ಬಂತು. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? So both carbon and oxygen got negative charge. Now when I am treating with two molecules of HCl, what this HCl will give? It will give two hydrogen, H plus ion. Correct? So add two hydrogen, one to the carbon and one to the oxygen. ಅವಾಗ ನಿಮ್ಗೆ ಏನ್ ಬರುತ್ತೆ? So you will get CH3. So now what I did, I am adding hydrogen, one hydrogen to carbon and one hydrogen to oxygen. O minus ಇರೋದು ಏನಾಗುತ್ತೆ? OH ಆಗುತ್ತೆ. Correct? And we know that oxygen is having lone pair of electrons, right? It can accept one more hydrogen. So here again from the HCl where you get H plus and Cl minus ion, this oxygen can accept the one more hydrogen. So when oxygen accepts one more hydrogen, what happens, students? OH ಇರೋದು ಏನಾಗುತ್ತೆ? Yes, OH2 ಆಗತ್ತೆ. Correct? So here it becomes OH2 plus. Now can I remove this part as water, H2O? And this bond comes as a negative charge on the carbon atom, right? So now what will be the next step? CH3, CH2 minus, because this is removed as H2O. Now again through HCl, H plus ion will be added through this negatively charged carbon, and what you get? CH3, CH3, that is a hydrocarbon ethane, right? Is that clear, my dear students? See, once again, let me explain you the Clemmensen's reduction. Here what happens, you have a acetaldehyde, that is CH3C double bond OH, and acetaldehyde on reduction with zinc amalgam and concentrated HCl. Very simple way of understanding is you convert the C double bond OH group to CH3, remove oxygen and add two hydrogen. This is a simple way of understanding. And for a clear understanding of the mechanism, you can take a screenshot of this. What happens here? The zinc, which is a highly electropositive metal, gives electron to carbon atom, and then what you do, you add one hydrogen to oxygen, it converts to OH, and one hydrogen to carbon and it becomes CH. Now this OH is next step, it is converted to OH2 plus by addition of hydrogen. Now remove this as H2O. When the water goes out, the carbon again gets negative charge and it accepts one more proton and converts to methyl group CH3, and what we get will be hydrocarbon. Is that clear, my dear students? Take a screenshot of this mechanism and understand. So any example is given, you can predict the product. So for example, now same way, if acetone is given, the same mechanism, if they give you CH3, C double bond O, CH3, in exam if it is asked like this, what happens when you treat this with zinc amalgam in the presence of concentrated HCl? Immediately what you can do, the carbonyl group, you remove the oxygen atom and two hydrogens will be added, so it converts to CH3, CH2, CH3, which is a hydrocarbon propane, right? This is a very simple way of understanding Clemmensen's reduction. Hope you are going through the session, students. ಸೊ ಈ ಥರ ನೀವು ಓದಿದಾಗ ಏನಾಗುತ್ತೆ, ಯು ವಿಲ್ ನೆವರ್ ಫರ್ಗೆಟ್. ಅದರ್ವೈಸ್ ವೆನ್ ಯು ಜಸ್ಟ್ ರೀಡ್ ದ ಟೆಕ್ಸ್ಟ್ ಬುಕ್, ರೀಡ್ ದ ಡೆಫಿನೇಷನ್ಸ್ ಆ್ಯಂಡ್ ರೀಡ್ ದ ರಿಯಾಕ್ಷನ್ಸ್, ಯು ಎಂಡ್ ಅಪ್ ಬೈ ಹಾರ್ಟಿಂಗ್. ಕರೆಕ್ಟ್? ಸೊ ನೀವು ಬೈ ಹಾರ್ಟ್ ಮಾಡಿದಷ್ಟು ಅದು ನಿಮಗೆ ಜಾಸ್ತಿ ದಿನ ನೆನಪಲ್ಲಿ ಉಳಿಯಲ್ಲ. ಯು ಫೀಲ್ ಇಟ್ ಈಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಟು ರಿಮೆಂಬರ್. But when you have a clear understanding, definitely you will not forget the reaction. Okay, this is how you make the organic chemistry concepts easier. At last, we will discuss one more reduction reaction that aldehydes and ketones undergo is Wolff-Kishner reduction. Here also, what we are going to do is same. Even in the Wolff-Kishner reduction, we take aldehydes and ketones and convert to its particular hydrocarbon. So if you observe here in the example that I have displayed, here also what happens, the ketone is taken, that is C double bond O, the carbonyl group is converted to CH2. ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀರಾ, the two alkyl groups remains as such, it remains same. ಈ carbonyl group ಏನಿದೆ, C double bond O group is converted to CH2, hydrocarbon. But what is the reactant we have taken? We have converted aldehydes and ketones to hydrazine. Hydrazine andre NH2 NH2. Okay, so hydrazine also in the presence of a base. So how to remember, students, Clemmensen's reduction ali we had taken acid medium, that is concentrated HCl. In Wolff-Kishner reduction we treat with hydrazine in a basic medium. Basic medium yaudu? Potassium hydroxide in ethylene glycol as a solvent. So you can observe here. So when you treat with hydrazine in a basic medium with ethylene glycol as a solvent, ನಮಗೇನ್ ಸಿಕ್ಕಿದೆ, hydrocarbon ಸಿಕ್ಕಿದೆ. So shall we work on it? Yes, let us work on it and see how we got the hydrocarbon. So ನಾನು ಏನು example ತಗೊಂಡಿದ್ದೆ? Yes, I had taken ketone, right? You can take aldehyde or ketone. ನೀವೊಂದು R ಹೆಚ್ಚು ಹಾಕಿದ್ರೆ aldehyde ಆಗುತ್ತೆ, ಎರಡು R groups ಹಾಕಿದ್ರೆ ketone ಆಗುತ್ತೆ. ಸೊ ಇದನ್ನ ಯಾವ್ದ್ರ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡ್ತೀನಿ? I treat with hydrazine. For your better understanding, let me write hydrazine like this. That is for the better understanding of the reaction. ಹೈಡ್ರಜಿನ್ ಈ ತರ ಬರ್ಕೋತೀನಿ. ಏನು ಹೈಡ್ರಜಿನ್ ಹೇಗಿತ್ತು? NH2 NH2 ಅಂತ ಇತ್ತು, ಕರೆಕ್ಟಾ? So what happens here? First you remove this part, minus H2O. ನಾನು ಮಾರ್ಕ್ ಮಾಡ್ತಿರೋದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಿದ್ದೀರಲ್ಲ, ದಿಸ್ ವಿಲ್ ಗೋ ಔಟ್ ಆಸ್ ಮೈನಸ್ H2O. ಹಾಗಿದ್ರೆ ಈಗ ನಮ್ಮ ಹತ್ರ ಏನಿದೆ? CH3 CH3 ಡಬಲ್ ಬಾಂಡ್ H2O ಹೋಯ್ತು. ಈಗ ಏನು ಬರೀತೀರಾ? ರಿಮೈನಿಂಗ್ ಕಂಬೈನ್ ಮಾಡಿದ್ರೆ ಡಬಲ್ ಬಾಂಡ್ NH2 ಇದೆ. ಇದನ್ನ NH2 ನ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಬರಿತೀನಿ. ಏನಕ್ಕೆ ಅಂತ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ, ಫಾರ್ ದ ಬೆಟರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಆಫ್ ದಿ ರಿಯಾಕ್ಷನ್. So this is what we have, correct? Double bond NH2. So students, this is nothing but we call it as hydrazone. Hydrazine itto, this intermediate we call it as hydrazone. Now next step ನಾವು ಏನು ಮಾಡಿದ್ವಿ? We have treated with a base potassium hydroxide. You know that potassium hydroxide on ionization, it gives K plus and OH minus ion, right? So this OH minus can grab a proton H plus, correct? So when it grabs a proton H plus, this bond comes out as a negative charge on the nitrogen atom. So what happens? CH3 CH3 double bond NH minus ಅಂತ ಬರಿಬೋದಾ? Is that clear, my dear students? ಏನಾಯ್ತು? One hydrogen from NH2 is removed with the base KOH, OH minus. Now what I do? The shift of the negative charge here, and this bond comes out as a negative charge on the carbon atom. So now you can observe CH3 alkyl groups ಹಾಗೆ ಬರಿತಾ ಇದ್ದೀನಿ. ಏನಾಗುತ್ತೆ ಈಗ? ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಆನ್ ದ ಕಾರ್ಬನ್ ಆಟಮ್, N double bond NH, right? Now, when there is a negative charge on the carbon atom, immediately you treat with water. You know that water will split into H plus and OH minus ion, and this H plus ion, when it attacks the carbon atom, ಈಗ ನಮ್ಗೆ ಏನಾಯ್ತು one hydrogen is added to carbon atom, right? So add one hydrogen. So now N double bond NH. Is it clear, my dear students? So what I did, I added one hydrogen to carbon atom. Now again repeat the same. Treat this with KOH, potassium hydroxide. So what this OH minus will do? It takes one hydrogen from NH and the nitrogen gets negative charge. So this negative charge comes here and this bond goes out on the carbon as a negative charge. So right, so ಈಗೇನ್ ಬರುತ್ತೆ ನಮಗೆ ಪ್ರಾಡಕ್ಟ್ ನೋಡಿ CH3 CH3 negative charge on the carbon atom and ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ this will become N triple bond N which goes out as a nitrogen. And again when you add one hydrogen, so ನಮ್ಗೆ ಏನ್ ಬರುತ್ತೆ ಪ್ರಾಡಕ್ಟ್ CH3 CH2 CH3, correct? This is a mechanism I'm explaining you about Clemmensen's reduction. So students, you can take a screenshot of it. Once again, let me explain you Clemmensen's reduction. So what you can observe in the simple way of understanding Wolff-Kishner reduction is you take aldehyde on ketone. When you treat with hydrazine, it forms an intermediate. This intermediate, which is called as hydrazone, on treating with a base, potassium hydroxide in ethylene glycol, the carbonyl group you will convert to hydrocarbon. That is a simple way of understanding is you will remove oxygen and add hydrogen atoms, right? So if you want a clear picture of the mechanism, what happens once the intermediate hydrazone is formed, the base OH minus takes out, keeps, first it takes out one hydrogen. Again here it will take out one hydrogen from the nitrogen atom. So and finally the nitrogen part will be removed as nitrogen gas N2 and keep adding one hydrogen to each carbon atom. See, here I added one hydrogen to carbon atom. Again here I will add one hydrogen to the carbon atom. Finally I will get the product CH3 CH2 CH3. Students, if still any confusion, repeatedly you can watch the session and understand. Fine. So in today's session we discuss some of the important naming reactions that we come across. Yes, there are many other naming reactions as well that I'll be discussing in the next session. In today's session, I hope you all have understood what is Rosenmund's reduction, what is Stephen reduction, and what is Etard's reaction, which we use to prepare aldehydes, and also the one of the important chemical properties that aldehydes and ketone shows is Clemmensen's reduction and Wolff-Kishner reduction. So easily exam point of view, there is a easy method to understand Clemmensen's and Wolff-Kishner reduction. But for your entrance exams point of view, if you understand these mechanism, that will be helping you a lot. ಸೊ ನಿಮಗೆ ಮೆಕ್ಯಾನಿಸಮ್ ಅರ್ಥ ಆದರೆ ನೀವು ಯಾವುದೇ ಟ್ರಿಕ್ಕಿ ಕ್ವೆಶನ್ ಕೇಳಿದ್ರೂ ಕೂಡ ನೀವು ಈಸಿಯಾಗಿ ಆನ್ಸರ್ ಮಾಡೋದಕ್ಕೆ ಸಾಧ್ಯ ಆಗತ್ತೆ. So students, next session I'll be coming with some other important naming reactions from aldehydes, ketones and carboxylic acid. So go through all the session and all the recorded videos and keep waiting for more and more videos. And yes, as I told you, start practicing. So even if you listen and just keep it as such, it will not help you in any ways. Okay, practice makes you more perfect, and practice makes organic chemistry very much easier. And yes, the teacher dot is with you always, and yes, you have to travel along with us to make your journey a successful one. And yes, students, I'll end up the session and I'll be coming with some other topics in the next session. Thank you all for being with me and listening to my session. Thank you, students. Thank you all.